Hello everyone. Hello everyone. Okay. Okay, good. Alright, welcome to tonight's Facebook Live session, happening every Wednesday at 8 p.m, brought to you by Heuristics. So today's topic will be quite big, but before I go into that, let me just introduce myself to our new friends here. My name is Kevin Huang. I'm the curriculum specialist here at Heuristics, and I've been teaching here since 2011. So it's been a long way, and still have many more years to come. I believe greatly in that. And in the course of my work, I've been involved in several projects, one of which is our total integrated learning platform. And later on, I will show you some of the works on that. And today's topic, the revision part, is based off one of the chapters of our Mastering Heuristics series titles, the unit transfer method, a problem-solving tool for challenging problems in upper primary mathematics. That's the full name, and I seldom use it. I seldom use the full name. So you can see that over here, these are the books. These are the book's contents, and it was first published in 2009. And let me just show you. It was first published in 2009, and after that, the second edition was reprinted in 2010. So this book was written by my mentor and boss, Mr. Sunny Tan. And in it, what we have are comprehensive workings and detailed explanation on how to solve the problems. And to complement this, we know that it can get quite intimidating for students. What we do is to integrate it into a mobile app, whereby it's much more interactive in terms of the explanation. So this will cover the book's content in an interactive way that may appeal more to students. So here you have a one-shot working, and over here this will be the interactive explanation. Okay, hang on. So the way it goes is that the solution will be shown more and more progressively, and there is also even a mandatory confusion alert to force you to stop and see where the choke points are. And this will go on all the way through. Okay, so that is what I was involved in, and later on you will get a chance to see this more in action. Okay, so now today's revision topic is a very central idea on model drawing. That would be the repeated identity. Alright, so for the unit transfer method this year, we've covered the first 4 common types of problems that every student should know. Okay, and today we will be covering the repeated identity scenarios. Last year we covered some of the excess and shortage and 2 variables in various Facebook lives. So this year, hopefully we will have a rerun on that. Okay, so today this is my main focus, and there's a lot of inquiries as to whether these are all P6 or not. Okay, the idea here is that they can be done for P4. All you have to do is to convert all these percentages or decibels into fractions first, and that would be something that the P4s are dealing with. Okay, so let me give you a rough idea on what repeated identity is. So for the first two questions, I'll do this by UTM and model, just to show you the connection, especially for the P5s this year, who will be learning more on abstract reasoning very soon. Okay, so here, let me just shout out back to everyone. Okay, right, so Alice's weight is 20% lighter than Bella's weight, and Bella's weight is 20% lighter than Carol's weight. So over here, think of it this way. This 20%, okay, let me use something lighter because I think it's alright to go light. 20% is 20 blocks out of a total of 100. For the P5s who haven't learned percentage yet, think of this as Bella's weight has got 100 blocks and Alice's weight is 20 blocks less than Bella's weight. So you are using like 100 blocks hang on, didn't write this clear enough. You're using 100 blocks to represent that total. So when we have this, we can convert this down to a fraction in the simplest form. Dealing with fractions in the simplest form is usually much easier because your numbers are much smaller. So over here, change this to 1 out of 5. And change this to 1 out of 5 as well. Okay, so the key thing here is that Alice's weight is 1 and Bella's weight will be 5. Okay, reduce it down to simplest form so that it will be easier to work with. Then once we have that, take note of this keyword here. Alice's weight is 1/5 less than Bella's weight, so this means that Alice must be 5 minus 1. Okay, so Bella's weight is 1/5 lighter than Carol's weight. So 1 goes to Bella, 5 goes to Carol. Okay, Unicorn, please stop spamming. Keyword here is lighter, so Bella will be 5 minus 1. How many percent is Alice's weight lighter than Carol's weight? So over here, let's define what this means first. So I will show you this in model form, and then I will show you this with the UTM form. Okay, in the model form, it goes like this. Okay, between Alice and Bella, Alice would have 4 blocks, while Bella would have 5 of these blocks. Agree? So up to here, there's nothing much, it's just defining the number of blocks. But now, if you are to compare this Bella with Carol, Bella's amount from the previous case did not change, and hence you want to draw the bar such that its length will be the same. Okay? And now this portion can be split into 4 blocks of equal lengths, and Carol's weight is going to be 5 of these pink blocks. So once we have done this, we want to ask ourselves, for this portion here, how should I cut it so that I can compare them uniformly? Okay, so the idea here is that the general idea is that because Bella's weight can be cut into 5 equal portions and 4 equal portions, you want to cut it into the lowest common multiple, which will be 20. So every one of these will have 4 units. Okay. Every one of these would have 5 units. Okay, for the primary 4 and primary 3s, most likely they will give you some friendly numbers to begin with. Okay, so for that you can still like cut it between 2 blocks and 3 blocks. You can still cut it out visually on the model. It's still alright. But when it gets larger and more unfriendly, we want to start to transit towards labeling of the models already. Okay, so this would be the case. Then for the C, you can see that there's a total of 25 units. So between A and C, how is percentage difference defined? But in this case, it's specifically how much lighter is Ellie's weight compared to Carol's weight. So over here, the percentage difference is equal to Carol minus Ellie's mass, and because you are comparing this against Carol, Carol will be the base or the denominator. Then we multiply this by 100%. Okay, one very important thing to note in your calculation is that if you are to type out all the numbers, do not include the percentage sign. The reason for this is because when you key in this percentage sign, okay, let me just show it to you first. The reason is that the calculator interprets 1% as 0.01, and the calculator can't think for itself. You have to do the thinking for it. Okay, so key this in only. You will see that you have 25 units minus away 16 units out of a total of 25. So multiply this by 100% and you will obtain 36% over here, which is your answer. Okay, so the way to compare this by ratio is going to be to list out A, B, and C. Okay, and you have to be aware that between A and B, you are comparing them on one layer first. Okay, A would have 4, while B would have 5 blocks. Then next up, we need to compare B and C on a separate line. So we put B over here and C over here. Ultimately, it will still come back to the same idea that you are comparing between 5 blocks and 4 blocks. You want to make them the same. Okay, because your B over here is the repeated item, we want to make them the same. So between 5 and 4, lowest common multiple will be 20. So we would multiply everything here by 4 to maintain equivalence. This will become 16, this will become 20, this will become 25. And then we will compare between Carol and Alice again. And you can see that this is much faster. But of course, you cannot totally disregard the fundamental aspect. You have to be able to appreciate the idea so that when you are faced with an unfamiliar problem yourself, you will understand how to deal with it. Okay? So remember to put this percentage sign if they ask for percentage difference. Okay, so do you all get it? If you got it, please spam the like button. Okay, yeah, Clarice got it. Daimena got it. Xingmingyong got it. Yes, it's 36%. Okay, very good. Okay, thank you all for your feedback. Okay, next up, let's go on to number 2, something a bit more challenging. So let me do this in 2 ways again, by model and by UTM. Okay, the reason for showing you the model, I always emphasize, it's not so much about speed and accuracy and all that. It's sometimes you have to understand what's going on before you can even start doing it. Would you rather do something fast, or would you rather do it right? You can think about what I said. So now, Andy, Ben, and Carol shared the sum of money. Andy's share was 4,700. The sum of the money received by Ben and Carol. So this sum of money received by Ben and Carol is going to be 7 blocks. Okay, well, this statement, this opening statement seems like it's not going to give a lot of information. This actually restricts that sum of money to be of a certain size. Okay, then at the same time, Ben's share was 2/3 that of Carol's share. And Carol received $105. Find the total amount of money received by the 3 children. Now for this question, you can still use model to solve it because it is still relatively friendly. There is a direct way of approaching it, which I'll show you in a while. So by the model, this is how it goes. Between A and B and C, treat this as one entire item. You have 4 blocks for A, and you have 7 blocks for Ben and Carol. Now if we look carefully at this, between Ben and Carol, if we are to combine them up over here, and we see that Ben has got 2 blocks and Carol has got 3 blocks, this would mean that their total would have 5 of these pink blocks over here. Correct? And 2 of them will go to Ben, 3 of them will go to Carol. Furthermore, we are told that Carol received $105. So once we know this, we would be able to see that. Okay, let me write this somewhere so that this is 105 divided by 3 to give you 35. Every one of this pink block can be found to be 35. Okay? And because these 2 items are repeated, they share that same total. So here, if I have 5 copies of 35, I would be able to get 175 over here. And because this 175 is now distributed across 7 of these blue blocks, this will give us 25. Every one of this will be 25. So in total, if I were to count everything over here, I would have 11 copies of 25. And this would give me 275. So the hard part about this question is to be able to recognize that you have to combine this up as the total and compare it with this B and C over here. So this is something that's still doable for P4s, albeit a bit difficult. Okay, very good. Then let's try something else. Try to do it by ratio. And this will set the stage for the question that I will go through in example 3. Okay, so you can see that if the students are quite unfamiliar with this type of abstract reasoning, they can still fall back on something that they've been working on for the last 4 years of their primary education, for the first 4 years of their primary education. So here, if we are to compare them, let's list out accordingly first. So over here, okay, here let me just make a confusion alert first. Okay, confusion alert. Please do not write this down. If you want to write this down somewhere that you can cancel off. Okay? A lot of us will be very used to writing the ratio in this form. Do you agree? So the thing here is, the trick here is not to write it out as individual items, because here, if you want to compare between A and B and C, this question is still rather easy. Later on, it can get quite messy if you try to do it this way. So what I would suggest instead is you define it according to the exact items that are given. You have A compared to B and C over here. So list that out accordingly. 4 goes to A, 7 goes to B and C. And then at the same time, between B and C, that ratio is 2:3. So over here, we've already covered this in the previous model way of doing. You want to look for a repeated identity and compare that. Cut everything into the same units whenever you can. Okay? So in this particular case, that repeated identity is B and C. So if we combine this up, we'll get 5. Then we say that these two are equal. We want to make them the same. Times this by 5, times this by 7. So this now becomes 20, 35, 14, 21, and 35. So once we've done it this way, you will see that 21 units, Carol's amount is 105. So 1 unit will then be 105 divided by 21 to give you 5. And the total amount that they have is 55 units. So doing this will give you 55 times 5, which will give you 275 as well. Okay, so usually for this type of question, when the information is given directly about someone, there would usually be 2 ways that you can solve it. You can solve it directly by reasoning, or you can do it by units equalization. Both ways will allow you to get the answer. Okay, so if you got it, please spam the like button. Okay. Yeah. Okay, this one is still rather easy. Thank you. Okay, yeah, so be careful on that. Try not to make careless mistakes on this whenever you can. Because ultimately, a mark is still a mark, and if you lose the mark because of some careless oversight, then that would be a pity, because you know how to do it. It's just that you messed up somewhere. Okay, so your metacognition still needs to be very tip-top. You need to be aware of what you're doing. Okay, so let's go on to something slightly more challenging. Okay, although it's a P6 paper, don't just dismiss the question just because it's P6 and your child is in P5. Even if your child is in P5, because the topic is on ratio, it can still be solved with greater understanding. So this is what I'll emphasize on. Now, Nelson, Jason, and Penelope received a sum of money. Nelson received half of what Jason and Penelope received together. So change this to half. 1 goes to Nelson, 2 goes to J and P. Then Jason received 4/9 of the sum of money. Okay, so the sum of money is the total shared between the three of them. And this first statement restricts that. Penelope received $15 less than Nelson. So what fraction of the sum of money did Nelson receive, and what was the entire sum of money? So to deal with this, let's list out what we have first. Okay, Rekha, you got it? Okay, let's list out what we have. Like what I said in the previous question, compare this with n to j plus p. Okay, so n will be receiving 1, j and p will be receiving 2. Okay, because I want to find out the fraction of the sum of money, you want to combine everyone up. And you will see that in the simplest form, Nelson received 1 block out of a total of 3 blocks. So we can answer A immediately. Part A must be 1 out of a total of 3 blocks. Okay? So the next part here is that we are told that Jason received, okay, leave a gap over here. Jason received 4/9 of the total sum of money. So you may prefer to write total over here. I prefer to write all the alphabets of all the initials of everybody's name. Okay, that's just me. But I think it is clearer. Personally, I feel that it's clearer. So I don't have stats to back that statement up. Go with whichever works for you. Okay, Jason received 4, and the total here is 9. And once we've got that, we can see that this question is very kind because it leads us into finding the repeated identity. There are some questions that do not lead you in this manner. So we can see that the total is being described on the first line, and the total is also being described on the second line. So we say that this is your repeated identity, make them the same. So 3 blue blocks length is the same as 9 pink blocks length. So we want to cut them all up into 9. Okay, this one becomes 9, 6, this one becomes 3. And once we've got this already, now we want to look back at the question for further information on what we can use. We are told that Penelope received $15 less than Nelson. Okay, I'm not too sure how to pronounce this. Okay, so Penelope or Penelope, not too sure. Okay, so over here we know how many units Nelson received. We know how many units Jason received, but we are not given Penelope's number of units directly. So that's something that we have to find out. So we say that P's number of units is going to be the total of 9 units minus of Nelson's 3 units minus of Jason's 4 units to give you 2 units. And this is the part that a lot of students have to be careful, because by the time you reach the last few questions, your mind may be, your brain juice may be depleted already. So this $15 is being compared to Nelson. It's not that Penelope received $15. Okay? So Penelope versus Nelson, we see that Nelson has got 3 units, we see that Penelope has got 2 units. So if we compare P minus N, the other way around, N minus P, this will be 3 units minus 2 units, which is 1 unit, and this 1 unit would have a value of $15. So what was the sum of money? The sum of money would be the total of 9 units. So 9 copies of 15 will give you 135. So the answer for B would simply be $135. Okay. Okay, got it. So of course you can still do this by model or fraction, but personally I find ratio to be the most consistent and easiest way to represent it, because everything is in whole numbers. Okay, and if given a choice, I would always convert it into a whole numbered question whenever possible. Now you can also, okay, Kelly is asking, to find Penelope's units, isn't it easier to just take the total units minus Jason and Penelope minus Jason? Now you can do that also. There's a lot of ways you can get P's units. I'm just taking the total and getting rid of all the individuals. Okay, so thank you for your feedback. Let's move on to number 4. So we still have time to spare. Yeah, okay, Uma is asking, is this session useful for P4? If you look at guided examples 1 and 2, the way I did it is by model and by ratio. Look at the model 1. The model 1 is the modeling is relevant for P4. Okay, on this repeated identity. Okay. Also for P5s who are transiting towards more abstract methods, this session will be useful. Okay, and also to help you appreciate what's going on inside the world of your primary math. Okay, this one please cancel out. Mike, Jill, Kenneth, and Jillian won a sum of money, which is $41,820. So Jillian received 5 out of 12 of the total amount received by Mike, Kenneth, and Jill. Okay, so let's list that out first. Allocate your units accordingly. 5 goes to Jillian, 12 goes to the total amount received by Mike, Kenneth, and Jill. So Mike received 3/5 of the total amount that was received by Kenneth and Jill. Next, Jill received 4 out of 11, as much money as Kenneth. Find the amount received by Jill. So over here, let's list out everything according to what was given again. Here we have Jillian. To Mike, Kenneth, and Jill all together. So this ratio we know is 5:12. Okay, a lot of you got it already. So let me just go through the whole thinking process first. Now, the next statement says that Mike received 3 compared to K and J's 5. Then after that, we are told that between J and K, J received 4, K received 11. Okay? So once we got this already, we want to look for the repeated items. In this particular case, you can see that here we have K and J. This is why I prefer to list out by individual initials. So we can see that if we combine up these two will also give you the same k and j over here. Okay, so there are two main ways that this can be done. So let me just save this screenshot first, and I'll explain the other way in a while. Okay, the first one is by units equalization. Wait, no, sorry, let me explain it by working backwards first. So this unit transfer method will help you to organize all your information so that you can see exactly what needs to be done. You see that everyone won 41820 in a lottery. So this total over here is going to be 17. And if this 17 units is 41820, then we can say that we want to take 41820 divided by 17 first. Okay, you're welcome, Rajeshwari. This will give you 2460. Then you can see that over here you have M, K, and J. The total would add up to 8 over here. So if I divide this by 17, I have 2460. I need to multiply this by 12 first. You know, my hand and brain coordination today is off. This will give you 29520. Okay, so if this is 29520, then this will also be 29520. Then we can divide this by 8 and multiply it by 5 to obtain what K and J received. So this will be 18450, and this would also be 18450. Then in order for you to find 4 units, you have to do 18450. 15 of these beige blocks is 18450. So to find out 4 of them, you have to divide by 15 to get 1 beige block first, and then after that multiply this by 4. Okay, and you will get 4920. So here you can work directly because your information is given. So it's very nice. Okay, but what if you are not given the information directly then? Then you have to learn how to tweak it, which is what we usually call units equalization. So to deal with it in units equalization, this is what you need to do. The first one is to list out everything. The total here is 17, and okay, this would be M plus K plus J. The color tone is a bit off for this. So you see that these two are equal. You want to make them the same first. So if we times this by 3, we will get 15, 24, and 9. Then we can see that this M and K and J is the same as this 12 on top. So we will make them the same as well. We'll multiply this by 2, so we get 34 over here, 24 over here, and 10 over here. Once we've got this ready, we can say that this 34 units must be that 41820. 1 unit will be how much? And because these beige units are already the same as all these subunits here, we can find out 4 units from here. Okay, if 34 units is 41820, 1 unit will be 41820 divided by 34 to give you 1230, and then 4 units. will be 4920. Okay, maybe for completeness sake, 4 times 1230 to give you 4920. Okay, both ways has their merits. For unit equalization, sometimes you have to do it because there is no, probably there's not going to be a way for you to do it by working backwards directly. Okay? Or you will need like two variable concept or something like this. So this way is one of the ways that you can use when you're comparing across different layers. Okay? Okay, please do not oof, please do not spam. Yeah, just make all the ratios the same. Can you make the denominator the same then divide? Okay, I got one question here. Can you make the denominator the same then divide? The answer is depends on the situation and what those denominators refer to. If the denominators are referring to the same total, then yes. Like for example, okay, for the benefit of everyone, let me just talk about this question first. By Edison Sim. The question is, can, wow, this one like very small. Okay, can you make denominator the same then divide? I would say not for this question. Okay? Because the fractions are referring to entirely different things. But when can you do it? Can be done when the denominators refer to the same total. What do I mean by the same total? The same total means for things like there is a pie. A took 1/3 of the pie. B took 4/5, cannot be 3/5 of the pie. Then C took the rest. This one you can make the same because you see that over here the denominators are referring to the entire pie. So that is when you can make denominator the same. Okay? This is a very good question. I think there's a lot of confusion over the fractions. But just be very clear that the denominator refers to the total number of blocks the item can be cut into. And in this case, the item is the pie. Okay? So with that, I hope you've enjoyed this lesson. And for this entire unit transfer method, we have a parents webinar specially designed for parents at the pace of learning pace of the parents, and it will be a hardcore 4-hour session happening this weekend on it. You can choose either the 13th or the 14th of April. Okay, and this we will cover the entire book on the unit transfer method. This will only be one part of it. There will be a lot of other chapters, and it's a hardcore session. Okay, you're welcome, Wendy. So let me just type out the thing real quick. Okay. And let me just briefly describe what you will get. Okay? When does lesson end? Now already ended. But tomorrow you still have one more session with me at 10 OP. Okay. Okay, you're welcome, Rekha. So here's what you get when you sign up for the UTM Parents webinar. The first of all, you'll get the unit transfer method ebook. You can choose whether you want P4 or P5 and 6. Okay, this is a digital copy of the same exact book that we have over here. Second of all, you get the webinar notes. Because without the notes, it's very difficult for you to follow the lesson. And if you listen passively, I can assure you, you will fall asleep. You will find that my voice is very nice to fall asleep on if you listen passively. The third one. Okay, you're welcome, Aggie. The third one will be access to the web videos, which will help you follow the flow of the explanation of the guided examples. The fourth would be on the mobile app itself, with all this interactive explanation over here. Okay? And the fifth one is on consultation on books, virtual consultation on books. Or rather I should say, the virtual classroom that we have with 𝗪𝗵𝗶𝗶. Two lessons worth. Okay? Yeah, this is what we have, and everything. Okay, let's not talk about those sales tactics. Let me just give you the price directly. Because I'm not a good salesperson. To be very honest with you, I'm not a good salesperson, so I'm not gonna try to do those like not 100, not 50, but 25. No, I'm not gonna do that. It's just $25. Okay? What time is tomorrow lesson? Edison, are you part of the 𝗪𝗵𝗶𝗶 thing? Okay, you're welcome, 𝗪𝗪𝗁𝗁. Okay, you're welcome, Uma. Okay, so here, for those of you who can't get enough of practice questions, don't worry, there's one place that you can obtain even more additional practice questions. That will be on our Facebook group. www.facebook.com/groups/maths heuristics. Okay, so here you can come inside here and I want to type some more. How come? Hey, hang on. Okay, what is that? Okay, then you can search for, use the text to search for repeated identity. Okay, I'm not sure whether you all can see it. Then secondly, I'd like to thank Leslie and Mr. Edwin Go for contributing to this. They've been contributing the answers a lot inside our group and also in other forums. So I'd like to thank them for this, for their efforts on this. Okay, maybe they find it a bit awkward that I mention it, but yeah, I think gratitude is one important attitude that everyone should cultivate. Okay? You're welcome. Where do I see all your topics? Okay, Edison, later I get back to you on that. Okay, you're welcome, Rashida. Hmm? Okay. Okay, wait, hang on. Oh, I didn't pin it. Wait. Okay, you'll be able to see it now. Okay, hang on. Okay, so if there's no further questions, then I'll take my leave now. This is Kevin from 𝗪𝗶𝗃𝗃 signing off. See you all soon. If you have questions, just leave them in the comments, and then we'll get back to you on that. Okay, see you all soon. And if you need to retrieve the notes, you can do so by visiting our blog. It's on our website. And from the website, you can come to this blog here. There will be several of these things that we've archived. So that's one convenient way that you can access all these for further revision. Okay? Some of the videos, we have linked them to our YouTube videos because there's some issue with Facebook recently. So those are our backup. Okay? So anyway, thank you all for having me. This is Kevin from 𝗪𝗶𝗃𝗃 signing off. See you all soon. Bye bye.